Hi, and welcome back, Math 257. This is for M14. You're almost through the semester. And this week we're going to have two big ideas, one being volume, and the second one being cubes specifically and folding into a cube or not. So three-dimensional geometry. So the rating scale for this week, for the first day on volume, I've rated a yellow. Depending on your past experiences with volume, you might be really good at this, or not. But this is also, remember, we're looking at the why behind. So we're really looking at where these formulas come from. And if we're in person, we're going to perform these experiments, which is extraordinarily helpful because it's hands-on and it'll help you ask questions and really get a feel for where these formulas are coming from. If you're doing this asynchronously, I have videos that go along with it. So that will be almost as good as the in-person investigation. So we're going to talk about what units is volume measured in and why. And then we're going to look at concrete examples of volume. And then we're going to compare, this is our experiment, two big things. The volume of prisms and how to find them, and then an experiment with cubes versus pyramids and comparing their volumes and in turn their formulas. And then cylinders and cones. And you might see some similarities between those objects when you just think about them, but we're really going to dive into the volumes and how their formulas are related as well and how we get those formulas. And then the last one we'll look at is the formula for a sphere. So again, hopefully you'll come in person. We're going to be doing experiments where you can make predictions and then we'll actually figure out the answer. And if you're doing it online, you'll do the same thing, but through a series of videos. So eventually we will come up with the volume formulas, and there are volume formulas on the final exam, and you can use the formula sheet for that geometry assessment. You won't have to memorize the volume formulas. So that's the first day. As always, check Canvas, do your exit ticket. The second day this week is we're still in three-dimensional geometry, but we're specifically talking about cubes. So again, I've rated this yellow. It's about average. The hard part about this is spatial reasoning. For some people, spatial reasoning doesn't come very naturally, and we have to practice to improve our spatial reasoning. I'm one of those. So in other words, when I look at a net of something, will it fold into a cube? If I get a basic net, I'm fine. Yes, I know this folds into a cube. But when I get a different type of net, sometimes I can't tell. So let me show you an example of these. Which ones of these fold into cubes and which ones don't? That can be a little more challenging, especially without actually folding the paper. You're wanting to be able to do this thinking in your head. And this is what students are asked to do on their standardized tests as well. So we will look at cubes specifically. We're also going to talk about some of the errors that kids typically make when they do this. And the best thing about this day is we are going to do stations. So, or centers, you might call them as an elementary school teacher. You know how students will travel to different parts of the room, and often sometimes the teacher is even a station. Lots of time teachers use this in reading, but they fail to see the power of it in other subjects, specifically math. Um, Centers can be amazing. I used centers in my middle school grades for math specifically and even algebra. So when you come to class, we'll be traveling to different stations to complete these activities. And it's a really great way for you to see how it can work in a classroom, but also how you can get a lot of hands-on activities. So These are some statements that elementary students gave about prisms. We'll compare prisms and pyramids. We'll discuss all the different names of them. And we're really going to start to focus on Euler's theorem. So, and what Euler's theorem is and how it applies to these polyhedron, which are three-dimensional shapes that are made out of polygons. So, this is a biggie, a great day to be in person. I hope to see you there. As always, check Canvas and try your exit ticket. Thanks.